Six, the Cartesian plane. So learning objectives. Graph points on the Cartesian plane, aka the rectangular coordinate system. Graph equations by plotting points. Find the x and y intercepts of a graph, both graphically and algebraically. So here is the plane, right? AKA rectangular coordinate system. Here in the middle, right? That's called the origin. Horizontally, we have the x-axis. Vertically, we have the y-axis. Remember that for quadrant 1, we have positive x's and positive y's. And then quadrant 2, negative x's, positive y's. Remember, it goes in this counterclockwise direction. Then negative, negative, and last positive, negative. Remember that each point here in the system is x comma y. So it would be a point on the plane. So a point is called an ordered pair because it's in a specific order, specifically x horizontal first, and then y vertical second. So that's why it's ordered pair because two. So it's just two-dimensional, right? There is the 3D plane. In 3D, we generally call the third plane the z plane. But that's not until later, not really even in this class do we talk about 3D. So it's a point in the plane is defined as an ordered pair, x comma y, such that x is determined by its horizontal distance from the origin and y is determined from its vertical distance from the origin. And again, remember the origin is that point right there in the middle. But you're probably familiar with that. So here's the first example, just plotting the points. So A is -2, 4. So you go -2 on the x and then up 1, 2, 3, 4, and then you find where those points cross, and that is A. So I want you to pause the not the video, so silly. Pause the video and label B and C. All right, B is 3, 3. So 1, 2, 3, and 1, 2, 3 on the vertical. So here is B, and then C is 0, -3. So then it's -1, -2, -3. So C. We would actually call C a y-intercept. If I can write the y-intercept, pretend like that says y-intercept, because it crosses the y-axis. If I were to plot another point, say right here, then that would be an x-intercept. Perfect. So graphing equations by plotting points. So that's just kind of how we start off in the beginning. Like pretend like you don't know anything. So basically what we're going to do is create a table with inputs, outputs. So 1, make a table with one column labeled X and a second column labeled Y. So again, you have your input, output. So if I have my table X, Y, write your chosen X values down in the first column. Make sure to use positive, negatives, and 0 if possible. I generally just kind of go -2, -1, 0, and maybe 1. Maybe a +2 if I need it. I mean, you can go crazy if you want to go crazy. I don't, especially because generally your given graph is not very big. 1, 2, 3, 4, 5, 6. Yeah. So this is a 6 by 6. 1, 2, 3, 4, 5, 6. So over here in your input, I would not really go above and beyond negative or +6 in either direction, just because your graph over here just, doesn't accommodate for it. Let me erase all this stuff. Okay. So 3, substitute the x values into the equation and calculate the y, plot the ordered pairs, and 5, connect the dots. So I know that this is linear. Hopefully you do as well. We've talked about it briefly in class. But remember, whenever your degree is 1, that's how we know it is linear. Whoops. There we go. So it's just a slanted line. All right, so if I do -2, that means I put in -2 in for x. So -2 times 2 is 4, -1 is 3. So I now have the point -2, 3. So -1, -2, 1, 2, 3, 2, 2, 2. So there's that point there. And then we pop in -1. So, oh, let's see. No, that's not -3. Y'all are screaming at the screen as you should be. Bloop. Do 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 do. Because that's negative, negative. Hello, silly lady. 2 times -2 minus 1 is -5. Hopefully, y'all were screaming at the screen. So 1, 2, and then 1, 2, 3, 4, 5 down. There we go. Much better. And then 2 times -1 minus 1. That's -2 minus 1 is -3. If you're familiar with slope, technically we haven't talked about it yet, but remember this is up 2 over 1, up 2 over 1, up 2 over 1, because this is the slope, right? Again, technically we're not there yet. We are just graphing by inputs, outputs. But if you know what that is, then more power to you to go ahead and just graph that way. Right, see, then we have 0, comma, -1. Oh, my up, down is not, oh, because I went over 1. Sorry. Again, y'all are just yelling at the screen. This is why I don't like making these videos. I need you to tell me all these silly things I'm doing. Up 2 over 1, up 2 over 1, up 2 over 1. And let's check. So then 2 times 1 minus 1 is 2, minus 1 is 1. So yep, so then we end up with the point 1, 1. So all of our points again are -2, -5, -1, -3, 0, -1, and 1, 1. Then we can just connect the dots. Ooh, hopefully yours is much prettier than mine, but voila. So I want y'all to pause the video and graph example 3. Come back when you're ready. Let's see. Oh, it's like a gray. Interesting. Let's take that off. It like changes my colors when I'm on night mode, which is weird for my brain. Anyways, ooh, this is fun. Pink. Oh, maybe that's what it usually is. Let's go. Oh, I don't know. How about, ooh, sparkly. Sparklies it is. So X comma Y. Again, -1. Oh, let's go -2, -1, 0, 1, 2. Let's do 4. So we're going to pop these in. So -2 squared plus 3, -1 squared plus 3, 0 squared plus 3, 1 squared plus 3, and 2 squared plus 3. What do we get? -2 squared is 4, plus 3 is 7. 1 squared, -1 squared is +1, plus 3 is 4. 0 plus 3 is 3. 1 squared is 3 plus, or excuse me, obviously, 1 squared is 1, plus 3 is 4. 2 squared is 4, plus 3 is 7. So now we have the points -2 comma 7, -1 comma 4, 0 comma 3, 1 comma 4, and lastly 2 comma 7. Now we're just going to plot. So -2, then 1, 2, 3, 4, 5, 6, 7. -1 up 4, 1, 2, 3, 4. 0, 3, 1, 2, 3. 1, 4, 1, 2, 3, 4. Wait, 1, 2, 3, 4. There we go. And 2, 7. 1, 2, 3, 4, 5, 6, 7. We're just going to connect the dots. It's like a pretty lilac color. There we go. Yay. So this is quadratic, right? We talked about quadratics. We know it's quadratic because we have a highest degree of 2. Let me erase my dots, my counting dots. Oop, it didn't like that. Okay. 1, 2, 3. There we go. And back to lilac. Oh, that's kind of squiggly. Hopefully your lines are straight. But again, technically right now, remember, you don't know anything but input outputs, right? You don't know slope. You're not familiar technically with functions of a quadratic. right, so now officially the intercepts. The intercepts have a graph are points at which cross the axes. The x-intercept crosses the x-axis, of course, at a point the y-coordinate is 0. So forever and always, the x-intercept, the y is 0. For the y-intercept, the y is 0. So whatever intercept you want, the other is 0. So for the intercept you want the other is 0. So like if I want an x-intercept, it's x comma 0. The y-intercept is 0 comma y. Yeah, so whatever intercept you're finding, you set the other one equal to 0 and solve. So far, we're just dot pictures. So I really want you to pause the video and try 4 all on your own. Then play when you're ready. All right, so we have an x-intercept here and a y-intercept here. X with no y, x and y here. X-intercept, x-intercept, y-intercept. Let's talk about it. So I have an x-intercept at -1 and a y-intercept at, what is that, 2? I can zoom in. Here we have an x-intercept of 3 and no y-intercept, because this is, as we can see, just a vertical line. Next, we have the x and y-intercept at the same place at 0, 0. And last, we have 2 x-intercepts, which is totally fine. We can have as many x-intercepts as the function calls for. So I have an x-intercept at -2 and 2, and then a y-intercept at, what is that, 1, 2, 3, -3. Perfect. Remember, graphically, we are just at the looking point only at this point in the notes. So what if we want to do it using a function? Well, find the intercepts of the equation and then graph. So for linear equations, you only need 2 points to draw the line. Only 2. Because we already know it's just a straight line, we just have to decide, well, how steep is it, right? How flat is it? So the easiest way to do that is actually just by, finding its x and y intercept. So again, if I want the x-intercept, the other is 0. So we set y to 0 and solve. So I'm going to add the 4. So 4 equals -3x. Divide by the -3. So x equals -4 thirds. Or what, -1.3. So -1 and then a little bit to the left. That sounds good. The y-intercept. Remember, whatever one I want, the other is 0. So y is equal to -3 times 0 minus 4. So y equals -4. So then 1, 2, 3, 4, just counting down 4. And now we're going to play connect the dots. Ooh, I forgot my sparkly pen. Ooh, but hopefully your line looks straighter than mine. I'm not that great at drawing this. Okay, fair enough. Good, and we can see that this is indeed a slope of -3, and we do go right one. So right one, oops, forgot I was a highlighter, so sorry. So over 1 to the right and then down 3. Oh, 1, 2, 3. I can count. Let's see. 1, 2, 3, 4. Why is my brain not working? It is 0. Oh, yeah, because that other point is going to be here. Okay, yeah, that's fine, because the next point isn't on the graph. That's why, silly goose. Ignore my ramblings. So there's a point between the x and y intercept, forgive me. Okay, so the distance, sorry, that's all six. I'll stop the video here and then I'll restart for seven. Yay, Cartesian plane.